Hello, everybody. Hello, hello. Thank you. Thank you so much for joining. This is week three or session three for us of the Road to Certification Associate Cloud Engineer series. My name is Roman. I am a GDG lead for GDG Lawrence. In on deck, we have also some of our co-organizers from GDG Cloud Twin Cities. We have folks from Capital Region. Thank you, Elaine. Thank you, Linda, for showing up. We also have Kevin, my co-organizer from GDG Lawrence, also on deck and ready to answer any questions that you may have. Also, we have some folks from GDG Hudson and GDG Suncoast. So welcome everybody to this session. As you know, this is our third session, bi-weekly session that we've been holding again in preparation for the certification at the end of this series. Hopefully to get the certification at the end of the series, where we've been dealing with cloud, how to get proficient in cloud so that we can take the Associate Cloud Engineer certification. So again, thank you everybody for joining. We're going to cover week three. We're going to be sharing these slides as well. And yeah, without further ado, let's proceed. So again, we're going to go over, we're going to ask, where everybody else is on their journey. Because again, this is supposed to be a community-centric effort, like all of us helping one another. We want to bring everybody up. We want to elevate, celebrate one another, and make sure that we all support each other in our journey to becoming cloud experts and also Associate Cloud Engineer certified by Google. So this is an amazing opportunity to do so. So where are you on your journey? Like I was showing, this our road to certification tracker. This is the one that tells us like where everybody is in their journey. I see a lot of people already on their way to accomplishing those badges and qualify for the vouchers that we're going to have at the end of the series, so that you can go ahead and take the certification, the Associate Cloud Engineer certification. Remember, one of the criteria is complete all the badges, attend all our sessions, attend most of our sessions at least, and make sure that you're ready and you're committed to go for the certification. So we see, yeah, I know that a few folks are not here. Some of their accounts haven't been added, but we're going to update it right after the session. But I see that a lot of you are already, well on their way to get that badge, to complete, to get the confidence that you need and the knowledge in the cloud, the know-how, so that you can become an Associate Cloud Engineer. So thank you, everybody, for joining. Carol, thank you for joining and bringing your community with you. Thank you so much. No problem, Mohammed. You have enough time to complete all your badges and be well on track for this for this amazing campaign. So, hey, Imad, how you doing, buddy? How's everybody? Great. So let's proceed. I just wanted to make sure that everybody was there. Everybody, is all good. Great. So now let's continue. That was where everybody else on your journey. That's an amazing tool that kind of keeps us in check and keeps the checks and balances for our cohort. So that was an amazing tool. Great. So for the Associate Cloud Engineer, we are now at week three, or session three, and there are two badges to be completed for that week. We're talking about in that specific week, we're doing Cloud Infrastructure Core Services. We're going to be going over some of those topics. And also there's a hands-on lab, which is an amazing lab, which allows you to set up and configure a cloud environment in the Google Cloud. There are amazing topics in there, amazing things to cover. I'm going to show those in a minute. I'm going to show you that. So let me I'll bring up the cloud. I'm going to have it ready, the cloud console, for those of you who want to check out a few things. We're going to do like some hands-on activities, but mostly going over the topics that week three covers, like in a nutshell, kind of like or an overview. It's everything from whatever is in those code labs and whatever is in the on-demand training and whatever is in the hands-on lab. That is what we're covering today, so that you can see if you have covered it. This is just a review, but if you haven't covered it, that's totally fine. You can catch up. This will be a preview of those topics. So let's begin. For this specific week three, badges are two: the Essential Google Cloud Infrastructure Core Services, and the Setup and Configure a Cloud Environment, which is a hands-on set of labs that you can complete so that you can get proficient in those topics. Let's start right away. One of the topics that get covered within in this week are about the identity and access management. In the last week, we actually covered a couple of these questions about IAM. What's IAM? In a nutshell, IAM is just who can do what on which resource in the Google Cloud. That's pretty much how you think about IAM, Identity Access Management, in the Google Cloud. Who can do what on which resource. Also, you also gonna review what the IAM objects are. We also talked about these kind of map to the same objects that represent the resource hierarchy in the Google Cloud, starting from the organization. Then the organization is like the topmost item in the resource hierarchy in the Google Cloud, then followed by folders, which are required where you want to create like some sort of logical organization in the cloud, in your environment, followed by projects, which are the ones that actually contain the resources. Resources are not like freely available or like loosey loose. They have to be attached to a project. And of course, you have roles and members, and we're going to discuss that in just a minute. Yes. John, so in order to be up to date, yes, you should have completed week 3, but don't worry, you can still catch up. But if you want to be up to date with the sequence of events that we're doing and the practices and all that, you should have completed it, but it's not mandatory. We understand that everybody has other commitments, but this is just like a nice to have if you had completed. But totally fine. I haven't completed it myself. I'm just missing one of the badges, but I'm all good. Like I'm gonna catch up, and I'm gonna make sure that I do complete that. But the same goes for everybody. Great. So we were talking about the organization node, remember, which is the root node for all the Google Cloud resources. It's kind of like what starts the hierarchy. You have an organization, and then other things can be under that. So if you see the organization roles, like you add specific roles, you have a specific organization roles. You have the organization admin, which kind of gives control over all the cloud resources, and it's good for auditing. They're just saying because you need to have somebody that kind of manages the whole organization and just wanted to see who provides access to who and all of that. That's why they say it's useful for audits. And of course, another or role that you have in the organization is the project creator, which controls project creation, creates all the projects, and controls over who can create the project. So it's not just for everybody. So those particular roles are very important at the organization level. Something else that we also are reviewed in some of the questions are the folders. Like, what are the folders and what are they for? Like, folders can not also like appear like loosey-loose, or they're just floating around there. They have to be part of an organization. And the reason why you create folders is mostly for grouping. So you group, you kind of provide like isolation or boundaries between your projects. For example, you can have one department like engineering or marketing, or let's say sales. You can have multiple folders, and then under those folders, you can have individual projects. You can create hierarchies of folders, but they provide, like, again, like you say, you can build, like, create folders for teams or departments, and they allow delegation of administration rights. You apply those rights to those folders, and they kind of trickle down into the projects inside of the folder. Also, they talk about the resource manager roles, which are like 3 levels. You have organization level, then you have admin and viewer. Admin, of course, as you know, full control over the resources. Viewer only views the accesses. They don't have any like, they cannot damage anything, they cannot change anything. They just can view things, but at the organization level, meaning they can view all the projects in your whole organization. They can view all the folders, all of that. Then under the folder, you have admin, creator, and viewer. Same thing. Admin, it's not the same as the admin at the organization level. The admin at the folder level can view has full control over the folders. Creator can browse the hierarchy and create all the folders, but you cannot do anything at the organization level. So you see everything goes like it trickles down, and then you see how the arrow points down. The policy inheritance goes down. Even though you're an admin at, let's say, at the folder level, that doesn't mean you have administrators in the organization. But everything down, yes, you can. Then you have the project, then you have creator and deleter. Of course, you see creator, you can create projects, and you can delete projects as well. So that is how it works as far as like roles at from the organization, folder, and project level. All of this is in that first batch. All of this. We're just going over real quick. We also mentioned this in one of the questions when we reviewed the questions last week, the three types of IAM roles. You have basic roles, predefined roles, and custom roles. I'm pretty sure that I think Linda mentioned very eloquently what these mean. That's why I love Linda when she participates in these sessions and she gives her expertise. So that's why the three specific, the three types of IAM roles are basic, predefined, and custom. This comes out on the test. Make sure that you know about these three roles. And then here we tell you now what the basic roles are. So we say basic, predefined, and custom. Within the basic now, you have owner. Owner means you can invite other members, you can remove members, or you can delete projects. You see, you have ownership on that basic role. Then you have editor. Editor is like you can deploy applications, you can modify code, configure services, and whatnot. You have viewer. Viewer only can view things. But then if you see, they are kind of like one contains the other. Like for example, you see editor contains viewer, and owner contains editor and viewer. It's like an accumulation of those levels of access, right? And then you have separate like the billing administrator, which can only manage billing, but then you don't have like other types of permissions. So when they kind of get grouped together, like owner, editor, and viewer under the basic roles, and then you have billing administrator, which is only for like manage the billing. Like your salespeople and whatnot, they have billing administrator, but you don't have anything to do with code or anything. So you can keep they kind of separate it like that. IAM predefined roles, we were talking about that they only apply to a particular GCP service in a project. These are like the fine-grained roles that you can apply to a service in a project. Like what can do on which type of resource. We were talking about those predefined roles that are different from the basic roles, because these are basic and they apply kind of like to the project. But then when you're here, you apply to a specific resource in a project, folder, or the organization. And the way that this works is like this. And I think Linda also mentioned a little bit like that. So a predefined role provides that fine-grained permission on certain services. So you can do, for example, you can have like you can list compute instances, or you see there are more fine-grained as opposed to like modify projects or view folders. No, this is like you can get VM instances, or you can delete instances. So you can provide specific roles, like those are predefined roles that provide access or the accessibility and modification capabilities to specific resources. In this case, they're talking about like permissions that you can add at the VM level, like for VMs. All of this is in week 3, like I mentioned. And the custom roles, now remember, we're talking basic, predefined, and then custom roles. Now you can define your own permissions. Like you can create custom roles, and then you can define a precise set of permissions under a custom role. So let's say this role, I'm gonna call it instance operator role, and then that one has for this role, I'm gonna say you can get, you can list, you can start, and you can stop, but you cannot delete. For example, I can create another role, say instance deleter operator, and I can just add delete permissions to that role. And then I can add people to that role, for example. I can add people to a group, assign that role to the group, and then that's how I manage it. But that's how you create like very custom roles, in GCP. Also, we're talking about during that week 3, we're talking about IAM policies, meaning that it's just a policy that consists of a list of bindings, and a binding binds a list of members to a role. That is how you set up your policies in identity access management. So that's how you do it. The IAM resource hierarchy, we keep stressing it because this is very important. They mention it all the time. You never lose this hierarchy. Organization, folders, projects, and resources. You cannot go wrong with this type of structure. You can memorize it if you want to. Organization, folders, projects, resources. That's the hierarchy in the IAM resource as well. When they're talking about resource hierarchy in the GCP, organization, folders, projects, resources. IAM hierarchy, organization, folders, projects, resources. It's always like that. And then if you see how, for example, everything trickles down, always pointing down, that some, let's say, some IAM roles are applied, and then they trickle down from the organization now. Service accounts are one of my favorite ones because service accounts provide an identity for carrying out server-to-server interactions. This means, for example, you want to, instead of being like a user, that you give it permissions, that you give it a specific role, you assign a service account that then will do that for you. For example, like a compute engine, a VM, that wants to talk to a cloud PubSub or wants to have access to a cloud bucket, like a cloud storage bucket. Instead of you as a user assigning, you have to have those permissions, you can assign those permissions to a service account, and then that service account be tied to a compute engine instance, and then you can make a call, you can fetch information from the cloud storage bucket or a cloud PubSub or anything like that. But they're kind of like, those are service accounts that are attached not to users, but to like, let's say, resources in Google Cloud. Again, a program running in a VM, like I mentioned, they can acquire access token with credentials as if it was a regular person logging in. And then tokens are used to access those service APIs, just like if it was a regular person like that. And they say service accounts are convenient when you're not accessing user data, but you're just, let's say, making a server-to-server interaction. So something to also know in the Google Cloud. And then if you see here, this is kind of like how it works. Like, default service accounts, you have basic and predefined roles for the default service accounts. Then you can create user-created service accounts with predefined roles, just adding some predefined roles in there. Or you can add like roles for service accounts just the same way that you can assign they can be assigned to groups or users. You can assign those same roles to a service account. The same way that you assign it to a user or you assign it to a group, you can do that to a service account as if it was a regular, another user, something like that. They mention about the two types of service accounts. Again, they say the two types of service accounts are Google managed and user managed. Then Google managed, they say that they manage all the managed keys. They store the private both the public and the private portion of the key. Each public key can be used for signing for a maximum of 2 weeks, and private keys can never be accessible. So Google manages everything for you, and those are the ones that you kind of gravitate to the most, because then those service accounts, you know that Google is going to take care of everything, of rotating the keys and all of that. As opposed to then you create your the user manage, you manage it yourself. You're responsible for the private side of the key, because there's a public key and a private key to establish that connection. And Google stores the public portion of that. But then you can only create up to 10 user managed service accounts, keys per service, and you can administrate via IAM API, G Cloud, or the console. So those are the two types that you need to remember: Google managed service accounts, user managed service accounts. They also mention about how you leverage and understand the resource hierarchy. Remember, we're also talking about from the organization, folder, project, resource all the time. So they mentioned these are some of the best practices. Like you use projects to group your resources that share the same trust boundary. Because remember, like services can be in multiple projects, but they are governed by that project. For example, you have a service in one project, you have a service on the other project. They're isolated, but even though they're the same under the same organization, the same umbrella, but if they're in separate projects, that's kind of how you do like that type of isolation. Also make sure that check the policy granted on each resource, and make sure that you understand the inheritance. Make sure that you provide like the again, I was going to mention it, but it's right there, is the least privilege principle. Make sure that when you grant a role to a user or you grant a role to a group, make sure that it's the amount of privileges and permissions that they need to do their job, not more, not less, only the least privilege, like the least amount of privilege that they require. They talk about also audit policies using cloud audit logs and audit membership of groups used in policies. Some of these things are good to know. They don't come heavily in the exam, but these are good to know because you really want to understand at least the best practices of like understanding the resource hierarchy, adding the proper roles, adding the least privilege principle. That's something that, is always good to know. And of course, this is the same thing that we keep mentioning. You don't grant roles to a user. You grant roles as a best practice. You grant roles to Google Groups instead of an individual. When you let's say update a group membership instead of changing IAM policy, that is the way to go. So you update a group membership, like you assign roles to a group and then you add folks to that group. You control the ownership of the Google group using IAM policies by doing just that. For example, you can create a network administrator group, like only the guys that deal with the networking. Then you can add them the role of view only and read write only. They don't need anything else. They only need to view the let's say the network and read write like some aspects of that. So and then you create a group and then you add the people in that group. So grant roles to a Google group, not to individuals. That is a best practice on that. They also mentioned about IAP, which is Identity Aware Proxy. You can enforce access control policies for your applications and resources. That is the way to provide, let's say when you have, this is kind of like to have like an authorization layer for applications accessed by HTTPS. You want to secure those applications. So then that's why you have that layer of some sort of like a proxy in there that for, let's say for your services that are HTTP accessed, you provide a identity aware proxy. And then IAM policy is applied after the authentication. So you have to authenticate your users, for accessing those secured resources behind, in the Google Cloud for you. So all of this, again, like I mentioned, I'm just going over these, but these are all in the week 3. Now we're talking about storage. I think some of you are really familiar with cloud storage and all the storage classes and the capabilities in the Google Cloud when it comes to storing data. Starting from the crown jewels of the Google Cloud, which are cloud storage buckets. So what is cloud storage? We've already gone over it, but let's go over it again. So cloud storage is an object storage service. They store blobs like objects. Don't think about they keep mentioning. Don't think of them as like files. Think of them as just binary blobs of data. Even if you drop a text file, that's a binary blob of data. So it's an object. That's what they want you to think of. So it's really great for like website content. It's great for like storing data for archiving and disaster recovery. We're going to talk about the different classes, how you pick one storage class over the other. It's great to also distribute large data objects via direct download. Like you can just give them a link to somebody and they can download that file, or in this particular case, this object. So that's why I keep saying file, but again, you know what I'm talking about. So now we have 4 types of classes of or cloud storage classes. There are 4. And I know that a lot of you already are familiar with those, but let's go over them again. So you have standard, nearline, cold line, and archive. This comes out in the exam as asking you like, what is the best storage class to pick when, let's say, we are, let's say, for example, like a law firm is trying to save their files for their clients that are older than a year. Which storage class can you pick? You already know what that is. So standard is the one for like data that is accessed like every day. They call it hot data. Very brief periods of time, you know what their availability is. Like you can look at their SLA, which is you can have it multi-region or regional, and it's like 99.95% accessibility in multi-regions and 99.9 in the region. And then standard is like for data that you need to pull every day. They call hot data. Then the next one up is the nearline, which is once every 30 days. So you can say nearline is more infrequently accessed, but it's the cheapest out of all of them because you have like a rough, like less than 30 days, but it's the cheapest because standard is more expensive because you need to pull it every day. The nearline is kind of like the happy medium. So it's infrequently accessed. It's good for backup and long tail multimedia content. That is the nearline. Then you have cold line, which is now, for example, let's say you pull your data every quarter, every 3 months. So you can do that. This is more infrequently accessed. This is much cheaper, but it's like you have access to that like almost like once every quarter. Oh, there we go. Yeah. Itamar, that's your, yeah, you saw that today, disaster recovery. Yes, exactly. Archive is for that disaster type of disaster recovery. So I'm glad that you saw that today. Great. So yes, and then last but not least, you have archive, which is the case that I asked you. Like if you're a law firm and you want to store data for your users, but at the cheap, and this data can only be accessed once a year, every year, once a year, then you go for archive. It's like more the long-term, data archiving, disaster recovery, online backup, like for longer periods of time, and it's really cheap. So people go for that because or for that like long-term disaster recovery and all of that. John, you ask, do we have to choose the type of data before we start adding stuff to the DB? When you can actually, there is an aspect of actually when you store your files in the, or you're talking about DB. Let's get to that point. Let's finish the storage classes and then we can get to that. But as far as like storage classes, when it comes to just storing blobs of data, when you upload, let's say, a set of files, the files that get uploaded to your bucket, they adopt the default class of the bucket. I think we can take a look at the cloud console, but you can, let's say, change the class of the files, but then any newcomers, any new files that come in, they inherit then the new change. So you can change the class, like even in the files that are currently there. Oh, you're talking about Karen says, why is the availability SLA for archive none? Because for example, in this particular case, it's none because they say, even though for example, they say it's like 99.9 accessibility. So they don't provide an SLA because whenever you pull information from the archive, I think what they refer with this is that, like, it's there, trust us, you can pull it and it's there. The other one is like when they say 99.9, it's like there's one chance in 1 million that your data may not be there or you cannot retrieve it. But in archive, they don't say that. They, instead of saying like 100%, they say none. Your data is there, when you pull it, even if it's once a year. So it's not like it's gonna be lost. The other ones, they give you that, like the availability and stuff. So it's a little weird, but they say that's how they say it. John, you say, what I mean is if I choose cold line for my data and then access it too often. Oh yeah, that's what I'm saying. Like whenever you do that, let's say you do like, okay, I'm gonna set it as archive, but then I'm gonna pull it every day. Immediately they they slap your hand and they'd be like, no, dude, you got to change it to archive. I think they penalize you for that, and they say you need to change it. So they'll probably change you at that rate, at the rate of the standard, right? Because you put it in archive, but then you're trying to pull it every day. I'm going to charge you at that level, at the standard. The data is there. It's just that you change the time or the frequency in which you access it. Like that, you change the class. But let's say you have a bunch of files in there. You can change the class anytime, but if you access it not in the proper class that it is, you're gonna get penalized, and then they're gonna charge you for that. Yes, yeah, exactly. Let's continue. Great. Cloud storage overview. Remember, we talked about that last week. We said that buckets need to be they have to be unique within Google Cloud. The names have to be unique. No two buckets have the same name. They cannot be nested. A bucket is like a flat structure. A bucket is like a one level type of deal. You don't have a bucket inside of another bucket. But you can create, again, unlimited amount of objects and drop an unlimited amount of objects in your bucket. No limit whatsoever. It's completely unlimited. There's no minimum. And you have a limited storage. They're just going to charge you. But it's not like they say, you cannot add another file. No, you got another file and you get the bill. That's it. Like if you exceed, let's say let's say whatever you have in there, but they charge you for that. And of course, we're gonna try now, for example, how to access the, let's say the right here. Where is it? I think I skipped that. Okay, there we go. So the gsutil command, you use it. That's how you access, let's say the Google Cloud through the Cloud Console. That's how you access your bucket. So if you want to access a bucket from the command line, the command is the gsutil command. And of course, cloud storage also gives you a JSON API or an XML API. So let's try it real quick, how you can access, or how you can create a bucket, even using the gsutil command right here from the Cloud Console. So for example, you want to create a bucket, you have to say GS util. I think I can zoom in a little less. Okay, here we go. So in order to access a bucket or to do something to a bucket, you use the gs util command. If you want to create a bucket, you say gs util mb for make bucket, and then you have to use this nomenclature. You have to say gs slash, and then you say like let's say Roman bucket, for example, something like that. Like you have to say GSU to MB, and then you specify like the bucket. Now I say, for example, authorize is going to try to create a bucket called Roman bucket. It says cloud browser name already exists. Oh, sorry, I already have one. There you go. So let me call it Roman bucket 081822, something like that. It can be more unique than that. So I'm creating a bucket called Roman bucket 081822. Let's see now that bucket if it got created. So if we go to cloud storage buckets, and then here you will see that bucket already created, and there it is. So I can upload things to that bucket. I can list the things in the bucket. For example, you can use either the Google Cloud Console or you can use the command line, and you can do that. For example, check this out. I can upload something to my, I can upload, let's say, a file to my to my cloud shell. So let me pick like a file. So I'm gonna say choose files. I'm gonna grab like one image. I'll say upload, and it's gonna upload it. So right here, I should have like one image called roman.png. So if I want to copy this image to my bucket by uploading it, it's pretty simple. It's as if you were copying a file from one folder to another. Check this out. You say gs util cp, like copy, the name of the file, in this case, what is it? Here it is, Roman PNG, and then I say, let me copy it. Let me copy this file to my bucket. So my bucket is gs//Roman bucket 081822. If I don't specify the name of the file, it will just upload the file and it will just name the same file as such. So if I click on the bucket and if I go inside, I should be able to have that image right there. And there it is. So you can just, right there, there's my image. You can list the things inside of that bucket. You can say, it's just like if you're listing a folder, you can say gs util ls gs Roman bucket. Let me just copy the name, or actually just the whole path. So I'm going to say ls, and it's going to list the files that are in that bucket. Oh, just copy that thing. So let me just do gs like that. And then it's just going to list the files in that bucket. And there it is. I can delete folders. I can delete the files in there. I can do anything. So you see, that is how you do it in the Google Cloud using the gs util, or you can just use the Cloud Console, and it's exactly the same way. Thank you, Elaine, for dropping that link. That was a great resource. Thank you so much, guys. Let's continue, and I'm gonna do presenter preview so that I can keep that window here, so I can switch back between the two. So we're talking about the cloud storage. We already did the gs util command. That was pretty cool. Access control, which they call, this is how you add access, control access to your buckets. You don't give access to everybody. At the beginning, you can put your bucket like blocked, and then you can either assign, let's say, somebody to that. Let's say you can add like a user to that bucket so that they can access the objects in that bucket. You can assign an access control list, meaning a list of users or groups that can access it. Or you can provide a signed URL. I kind of like these ones because a signed URL has like a time-based cryptographic key. You can say like, here, guys, this is a file that for you to download, but it will take, I will only have it available for a month or for 1 day. So hurry up and download this file. This is like if you're running a promotion or something like that. After they can use the signed URL anytime because it has a cryptographic key. It sends that key. It provides kind of like that authentication, and then people can download the file. Otherwise, after that time, let's say if you say a month or a day, they cannot access it. It's like nothing. Don't worry about it. So creating signed URLs is pretty cool. And of course, the signed policy document, which controls which file then people can download and all of that based on their like based pretty much like on the roles and all of that. And you can use them all together. You can have a signed URL of only a group of people with let's say IAM assigned to them, so you can use them all together. Pretty cool. And then again, they describe what an access control list is. An access control list is nothing more than, it used to define, who has access to what, to the buckets and the objects, as well as the level of access. So you can have only a maximum of 100 ACL entries, but an ACL entry can be one group with like 100 users in there. But you see, it's only one entry. But you can have then 100 groups. So don't waste your ACL entries in just individual users. You can do like add a group, and then you can add a bunch of people under that group. So that group is one entry in the ACL. So, and then the permissions that you can add to the ACLs are owner, like the owner of the bucket; writer, a person can write to the bucket; and reader, a person can just read the stuff in that bucket. But they cannot write and they don't own it. You can, and the default stuff that you can add are like, for example, here in the bucket, I'm going to show you, for example, like the access that my bucket has. So if you just go here and you click on that bucket, you can see, for example, like what type of permissions they have, who has access to those. You can prevent public access. You can add roles. I can come over here and say like add permissions. And then here you can add a principal. A principal is like, again, who has access to the role. I can say all users. There it is. All users means I'm going to make it public. And then you can say a role just by saying all users, that's it. And then I can also say all authenticated users. That is another type of principal that you can add. All authenticated users, that's another type of principal. And or you can select like a role. You can say, let's add, everybody. For example, like you could do other. Well, actually, I was going to say like cloud storage. I was going to go to cloud storage and then say cloud object storage viewer. So I'm going to say all authenticated users will be viewers, or all users, regardless, are going to be viewers in this bucket. And then you just do save. So now what this is doing is I'm going to make everybody able to view this bucket. Now I can, for example, generate like a link so that people can view this. You see, like public, I can say, prevent public access and all of that. Those are the things that you can do. Or use like the fine-grained object level ACLs. Like you can add single set of permissions, on the bucket, on that fine level of granularity. Object versioning, meaning like you can have a bucket. You can have an object and then you can delete it, but you can go back on the previous deletion. You can add multiple versions. For example, I can upload another one, and if I enable versioning, instead of overwriting the same file, let's say if I come over here and I go back to my objects and I try to re-upload that same guy, like, okay, I'm gonna upload that image again. Let's try this. If I upload it like this, and I call it, for example, something else, instead of like adding a duplicate, what it's going to do is actually do like versioning. Like, oh, this is another, if I have like versioning enabled, it will allow me to do like instead of like duplicating the file, what it's going to do is going to make it versioning. Like, oh, I uploaded one today and then another tomorrow, and then you can see that you have multiple versions of that same image. So that is object versioning on on a bucket. You can limit the number of versions. Don't make it like too long. You can say, let's only keep the last 3 versions of every object. Or you can say no versions. So that way it will always be overwritten, something like that. They also talk about something that I found really useful, that I've done it, is actually object change notification. If you upload a file, you want, let's say, another application to know that that file got uploaded, you can do so by enabling object change notification. And the way to do so is by doing, I think I've already explained this before, like you can set up like a cloud pub sub that is listening on that change in the cloud storage. Let's say when you upload a file, send a message to cloud pub sub, and then cloud pub sub execute a function or something like that. You can do so here, for example, when you create like you can come over here to a cloud function. Check this out. For example, you can do cloud functions. Let me show you real quick. You can create like a cloud function, for example. Check this out. You can create a cloud function and you say create function. I'm going to create a function. Okay. And then I say, what's going to be the trigger for this function. Like, what's going to make this function call? You can say cloud storage. On what? On what type of event? You can say every time I delete a file, or there's a metadata update in the file, or I delete the file, or I archive the file, or I finalize creating the file. Let's say I upload one file. I can say on finalizing creating the file in the bucket, I find my bucket. There it is. I just select the bucket. And now if I do this and I create this function, I'm going to call it, bucket function, for example. And then if I do save, I do next. Now I come over here and in my index.js, because I made it like for Node.js, see, it's going to say processing file, blah, blah, blah. Let's try this one. I'm going to leave it deploying because it may take a little bit. But what I'm going to do is I'm going to upload a file, and then you will go to cloud login, and you will see that when I uploaded the file, the cloud function is listening on that change. And that is exactly what object change notification means. So you can upload a file to that cloud storage bucket, and something happens as a result of that. What does it happen? A cloud function call. So something like this is pretty cool. So it's finishing deploying. I can take a look at that later. Let's continue with this. But you see, you can do pub sub notifications, but I wanted to add the cloud functions notification in there. This is pretty simple. I think this comes out on the test, but very minimal. Like they talk about, oh, your company wants to transfer files from your on-premises data center to the Google Cloud. These are the 3 types of ways that you can import your data, either into Google, from your on-prem to your own VPC in Google Cloud. So you can do transfer appliance, which is actually a rack that it gets sent to you. And then you can just rack it up, blah, blah, blah. And then you ship your data to Google Cloud. They rack it up. You have your own racks with the Google logo in there. Then you have the storage transfer service. Now is actually, this is, you can actually upload it, like import online data. And then they give you, I think this is the one that they give you like a device. They send you a device, and then the device gets shipped to Google. Then they transfer the data in there. And then the other one is the offline media import, which is a third-party provider, is the one that uploads the data from physical media. Like you have your data in tapes or hard drives or terabytes of data, and then they do that for you. So you can either do the transfer appliance. They send you a rack. I think Amazon does that, like with the Amazon Outpost. They send you like a rack. You have like your racks, and then they, you can send it to Google. And then you have your racks in Google like that, your servers in there, which is pretty cool. Let me see if this is done. Oh, this is done. So check this out. So let's go back to the bucket. I'll go back to cloud storage. I'll upload just another file in there. And you will see, for example, in my Roman bucket, I'll just say upload files. I will upload one file that has a weird name. Let's call it skipping frog, blah, blah, blah. So I'm just something in there. So after I upload that, just so that you can see the name, after it gets uploaded, then let's go to the cloud monitoring and see or actually even in that same cloud function, you can see the logs in that function. So if I go to cloud function, right here, cloud functions, and then I can look at the logs of that function. They should be able to output something that says, like processing files, skipping frog, blah, blah, blah. So let's see if that did that. So if I go to the logs, and then here you can even see the logs of your cloud function right away. So you can do that. There it is. See, processing file, skipping frog. So what it did is actually it interpreted that there was a file uploaded, and then you can do anything with that file. You can download it, you can process it, and pass it along to something else. So this is one of the things that I was talking about. You see how simple it was to do. It was just a few clicks, and then it was done. So that was pretty cool. Let's continue. So now I think this is especially for John. Because John, I remember last time, I can't forget, because you told me the other day, like, how do I learn all those terms? Here they are. Look at it. Now we're talking about other types of cloud storage, how you store your data now in the sense of like more structured and non-structured way of storing your data. So you have multiple solutions, multiple ways in which you can store your data in the Google Cloud. You can either, again, you can be hardcore and you can create a virtual machine, install your database in the virtual machine, and manage your own data, and you're good to go. That's on the left-hand side. Or you let Google manage it, and it's fully managed. They create the environments, they manage the patches, they manage the updates and all of that, and the resource allocation, the availability and all of that, the backups, the replication. You don't have to do any of that. You just have to worry about your data. So you have either a compute engine, or you have Cloud Bigtable, Cloud Storage, Cloud SQL, Cloud Spanner, and Firestore. Those are like the multiple variations of way that you can store your data in the Google Cloud. So let's continue. Real quick, again, all of this is in the week 3. You're gonna get exposed to that. So Cloud SQL is like a fully managed database service, and then behind that, you can pick what type of flavor of database you want to use. It's all like RDBMS. You can pick MySQL, PostgreSQL, or SQL Server, and then they provide the patches and the updates for you, like I mentioned. But you administer, of course, your SQL users. You can administer the users and you administer your data. But they take care of the patches and the updates, so that you don't have to worry about that. If you had done this, you do have to worry about the patches and the updates of your database. What I like about this is that you can use the Cloud SQL. You can use the gcloud SQL command in the Cloud Shell, and you can manage your SQL instances in there. You can use Cloud SQL, Cloud SQL for App Engine. You can use it for Google Workspace. You have a bunch of tools that you can talk to those databases, and you can connect, for example, SQL Workbench or Toad. And of course, by using SQL drivers, you can connect to those databases from other external applications. They don't have to be inside of Google Cloud. The next one is, for example, a Cloud SQL instance. Let's say one instance. In the Google Cloud, for example, you can do like that's why it's optimized for performance. So if you have something that has like 64 terabytes of storage, 60,000 input outputs per second, 624 gigabytes of RAM, you see like it's massive amounts of processing and data, something that you may not be able to do on Compute Engine. You're going to incur into like a big cost, like a big billing, right? And the cool thing about this is that it scales out with read replicas. What it does is create replicas of your, and then they scale out horizontally. So that's why they scale out. As opposed to scaling up, they scale out. I think they scale up as well. I think you can bump up the storage, the memory, and they both scale up and out. And then out, they do replicas. And of course, like I say, you could do MySQL, you can do Postgres or SQL Server. And then here, this is what I was talking about, like the replicas. So the replicas are like, you have high availability configuration. So what it does, you have a primary instance, which is the main SQL, and then you have one for in case and then you have it in different zones within the same region for high availability. If one goes down for some reason, the other one stands up and becomes the primary, right? Until then you figure out what the issue is. So one stands up as but then any transactions that you do in one region, in one zone, get replicated to the other one, just in case something happens to the first one. And I corrected myself. Now, see, you can scale up by beefing up your machine, or you can scale out with read replicas. Like when you have your primary instance and you have the standby, if one goes down, the standby becomes a primary, and then another one becomes the standby. And then they do the read replicas like that. So it's pretty cool. I think I skipped this one. This is just mentioning like when to choose Cloud SQL over another one, which is very simple. Let's say like if you need RDBMS, like you want relationships and stuff. No, okay, so then you can consider a NoSQL. But if you is your data more than 64 terabytes? Okay, continue. Is it maximum of 4,000 concurrent connections a day? Okay, continue. Yes, you need Cloud SQL. Is location management okay? Okay, continue. Do you have specific OS requirements? Yes. Okay, so then you can, if you do have specific OS, then you're going to have to go the VM route. But if no, then you can do Cloud SQL, and then you can follow along. Cloud Spanner is like it's kind of like Cloud SQL, but it's much larger. So now instead of talking about terabytes, we're talking about petabytes. It's like amazing. I haven't seen a petabyte of data, to be honest with you. It provides strong consistency and high availability because it's globally available. So it's like they say that they combine the benefits of a relational database, because you have tables and relationships, but the non-relational horizontal scaling. So that's what's good about Cloud Spanner. So they do have high availability, and then they say that they use it more for financial and inventory applications, but it's like it scales horizontally as if it was like a NoSQL, but it has the benefit of having transactional consistency and a strong consistency, scales to petabytes, and that relationships like the RDBMS type of style. And these are like the characteristics, how they compare it against like how Cloud Spanner has the benefits of relational and has the benefits of a non-relational DB. And then you see that is horizontal, that's kind of like a NoSQL. Vertical, no, they don't have vertical relationship. Like a regular Cloud SQL doesn't have vertical, let's say, scalability. They do have, like the replicas. That's as much as scalability that they have. And then you can see, for example, it has strong consistency. It has a SQL, but then of course that's a benefit. Like people see SQL as a benefit over NoSQL. But you see, you can definitely take a look at that. Cloud Spanner, that's how they say the architecture is. Like you see, Cloud Spanner is almost like having replicas, but this pretty much is like it's just saying instantiating replicas in different zones and even in different regions, and then that's how we make it very globally available. That's why it's very highly available, and they can be within a one region or across several regions. That's why it's like globally available. You can pick the region that you want to put your main database in, and then the architecture allows for high availability. Data replication, is synchronized, like they say, across zones using the global fiber network. That is the same, pretty much kind of like the Cloud SQL replicas, like the updates happen on the main zone and then it replicates in the others. This is just saying how you pick Cloud Spanner, like how you pick Cloud Spanner over Cloud SQL. They tell you like, okay, is it a single instance, RDBMS? Okay, so let's continue. Are you going to shard a DB, like you're gonna split the data across multiple databases for throughput? Oh, okay. So do you need transactional consistency? Oh, okay. So let's continue. Do you want global strong consistency? Oh, okay. If you need DB consolidation, yes. Okay. So then go for Cloud Spanner. If not, you can either consider Cloud SQL. But then if you just say I don't need full relational capability, okay, so you need something NoSQL. That's how they kind of explain it here. This is my favorite. I know I'm biased towards like Firestore because I love Firebase. And then Firebase Cloud Firestore is a NoSQL document collection database that simplifies storing, syncing, and querying data. It's NoSQL. This one is NoSQL. Is not, there's no relationships in here. There's no tables. It's documents and collections. And it's great for mobile and web applications. It has real-time capabilities, and it has ACID transactions. What I love about this is by default, it's multi-regional and it replicates globally. So that's what I like about it. So if this is kind of like, it's almost like Cloud Spanner, but NoSQL. And then it has a powerful query engine. And then, like I said, it has ACID transactions. It has a cool security features, and the real-time capabilities is amazing. And they consider this like the next generation of cloud data store. Some of you may confuse Cloud Data Store for Cloud Firestore, but Cloud Firestore is the next generation of Cloud Data Store. I'm assuming that they may phase it out. They may phase out Cloud Data Store over Firestore because it does provide pretty much like the same things as Data Store, but you have to change the mode. You can be in let's say in like classic mode, which is a data store mode with strong consistencies and compatible with data store applications, or the native mode, which is the regular Firestore for strong consistency, real-time updates, mobile and web client libraries. So it's easy for you to access the data in those databases. I love Firebase. Kill me with that. I love Firestore. I love it to use it not only as a just regular database, but use it as a real-time communication between my applications. I just love it. They tell you how you pick Firestore. How would you pick that over any other type of things? And I just don't want to kill the buzz on the next one, which I'm going to mention, which is Cloud Bigtable. Cloud Bigtable is like Cloud Firestore, but larger. You see, so you have Cloud SQL and then you have Cloud Spanner, both relational, but one is more potent and larger than the other. Now for NoSQL, you have Cloud Firestore and Cloud Bigtable. They're both NoSQL, but Cloud Bigtable is petabyte scale. You have sub the milliseconds latency. is seamlessly scalable for throughput. Like you use it for like IoT applications. You see right there, it says it for ad tech, fintech, and IoT. Good for like machine learning. And again, like it does scales like massively with large amounts of data. So think about Bigtable as like the parent of Firestore, like the big brother of Firestore.
Hey, Roman, the time check. 3 minutes
Yeah,
to
I'm,
9.
I'm taking a look at that. That's why I'm flipping through some of these because I'm just going over some of this real quick. I know I'm going a little bit fast, but again, this is all in week 3. And then let's wrap this up by just saying again, memory store is kind of like Redis in the Google Cloud. It's an in-memory data store service. You build great applications with that speed because all of that is in memory. You can create like instances of 300 gigabytes of data like in memory being processed for you. You can do high availability on that and easy lift and shift. I think the next section talks about like resource manager. This is like they're talking about like how again the same thing, how the identity access managers goes from top to bottom, while building a resource goes bottom to up. Like the resources belong to a project to a billing account, and the organization contains all the billing accounts. And they talk about, see, they keep stressing about the organization node being the top. Resource hierarchy, how certain things are global and regional or zonal. Like, for example, IP addresses are regional, while images, snapshots, and networks are global. Disks and instances are zonal because they live on one zone, like on a data center, like a disk, a physical disk, or a VM instance. But then when you're talking about IP addresses, they're like within a region, while then an image, like a VM image or a snapshot or a network, they're global. So those are things that you need to know about. They're talking about the quotas. We're talking about like why use project quotas. It's mostly to prevent large consumptions of your resources and to prevent spikes in your billing. They talk about labels. We talked a little bit about labels last time. I'm taking a look at the time. I'm about to finish. Labels are great for utilizing a great utility for managing your resources in the Google Cloud, and then you add labels to your resources. And this one actually comes out in the test. So make sure to know the difference between labels and tags. While a label is a way to organize your resources across your Google Cloud, tags are only applicable to an instance. You can only apply a tag to a VM, but you can apply labels to a VM. But tags, you cannot apply it to like a disk or an image, or you can apply it to a service or whatever. You can apply labels to all your resources, but tags are only used for networking, so that you can apply firewall rules to your VMs. So tags are only for VMs. They talk about budgets and email alerts. That's something that you can, take a look on your own. This is how you can look at labels to optimize your GC spend. You can perform like a big query. You can pull all the labels and you can say everything that is a VM, that whatever, a web VM. Let's see how well we're doing. So you can query it like that. And I'm just gonna flip through some of these, but this is something that you can. They don't go deep into this. I know we're already at time, but please take a look at this because it's a great section on the cloud, Google Cloud's Operations Suite, which used to be called Stackdriver. Now they call it Google Cloud's Operations, and then they have monitoring, logging, error reporting, trace, and debugger. Some of this, of course, comes out in the test. So I encourage you to review this section in this week's section. You just go over like some of the videos and you can take a look at that. I'm just gonna see. I was just gonna show you what monitoring is, login, that you can do login. I showed you some of the login already. You do error reporting, is just showing errors on your applications, and tracing, which is like for tracing your system in real time, and you can do stuff like that. And debugging, which is pretty cool. You can debug in the cloud. You can debug applications and look at even the line of code that is causing the error and stuff like that. So that's it. That's all I have. Again, I know that I went a little bit too fast, but these slides, yes, John, I will provide these slides. But like I mentioned, everything that I talked about just now is in week 3. Everything is in week 3 in greater detail. They're not going to go as fast as I went. They're going to go much slower, and they're going to explain each topic. And you're going to have labs where you're going to practice some of those things. I know we went a little bit over, but I just want to just tell you that week 4 is the thing for the next 2 weeks. If you're caught up on week 3, then you can proceed on week 4. Week 4 is 2 more badges, and they're talking about now scaling and automation, as well as another hands-on lab on automating infrastructure in the Google Cloud, doing like Terraform and stuff. This is pretty cool. So I would encourage you guys. Yes, I did cover a lot. I know. I'm sorry, guys, that I may have gone a little fast, but at least I just wanted to give like the 30,000 feet, 30,000 foot overview of what you will be seeing for this the next 2 weeks if you engage on week 4. But no, that's okay if you're not there yet. I just wanted to give you a preview on that. For those of you who just did it, this was just a review. I hope that you are caught up on that. So without further ado, again, make sure to always join our Slack group. Anybody who has any issues, please join our Slack channel. Ask us any questions. Please drop your badges. As you complete badges, drop it in there. We want to celebrate you. We want to give you thumbs up and all of that. So make sure to join our Slack group so that you can ask the proper questions. I hope everybody already here is. So, this was really good. Thank you, Linda, for dropping the link. And of course, they say redeem your participation badge. I didn't know they had badges for participation. You can get your badge. It's just that badge. I don't know what that does, but you can get one more badge. Anything else again, guys? I know we went a little bit over 3 minutes over, but I just wanted to see if anybody had a question before we wrap it up. But again, I just wanted to say thank you to all of you. Those of you who have been loyal to us, continue joining these sessions and finding value on these. Again, having a lot of fun during the office hours, answering questions, hearing Linda giving you, dropping dimes on knowledge about the cloud. John also chiming in. Jose, Hadid, you were there. Mohammed, all of you guys keep joining because you guys make this more worthwhile and make it so that we want to continue doing this. So, anybody has anything to say before we wrap it up? Kevin, Jeffrey? Yes, the link to the slides. Let me generate those for you.
All I can say is, once again, Roman, this is a great session. I think we covered a lot. And then there's a lot to I think that's a lot.
There's a lot. Right? There's a lot. That's why it takes
a lot
2
more
weeks,
to talk about.
It takes 2 weeks.
Even the work behind it to prepare it, we have to think even of that. It's a lot of work. Congratulations,
yes, it's lots
Roman.
of work.
Thank you so much for putting up all of this.
Linda,
good job.
Thank you, Jeffrey. Like I was going to say, Linda can be a testament to this. This is a lot of work. This is a lot of effort. But at the end, you savor that certification. You hang it up on the wall. You frame it because you're like, man, that took me a lot. That took me a couple of weeks to do. So yeah, and really, tears and blood and whatever, sweat. But you will see it. Like once you have that certification, you have that validation. You feel like, hey, I'm on top of the world. So please, guys, do the effort to, go over these topics, and you will be just like me, Kevin, Jeffrey, Linda, everybody, knowledge about the cloud and really, just spreading the word and really be a good cloud practitioner. So again, thank you, everybody. Those are the links to the slides. These are the same slides. Please go ahead and focus on we said focus on the 4th if you are there. If not, continue at your own pace and continue completing your badges. Thank you, Raj. Thank you, everybody, for joining. We will also post this video in the GDG Lawrence YouTube channel. This session will be there as well. You can listen to it while you mow the lawn, like I do. So yeah.
It will be kind of noisy. You have to put it
I know. But yes, thank you, everybody. Have a great night. We're going to stop the recording right now, just in case, but we're going to stop the recording. We're going to have it available. See you next week on the office hours, where we're going to be reviewing the questions for week 3. So we're going to be reviewing the questions on week 3, and we're going to be doing a lot of hands-on this time. We're going to be doing a lot of hands-on because it's a lot of like commands and stuff that we're going to be checking out. So thank you. Thank you so much for joining. Thank you, Adriano, Kevin, John, everybody, Raj, Mohammed, everybody, please. Thank you. Thank you so much for joining. This is amazing. You guys make it worthwhile. So see you next week. at the office hours to review the exam questions. Thank you very much, guys. Have a great week.
Thank you. Have a good night. Bye.